Hi guys, so there were a couple questions during tutorials about even, odd, neither functions, so I just thought I would make a quick video to go over it. So I'm doing the problems that I assigned for homework and that you probably already turned in, but let's take a look at these problems. So let's make our first, let's go over here and make our statements that we concluded. If it's an even function, okay, when I drop in a negative x and I simplify, I'm going to end up with the original function. And that is going to be symmetric over the y-axis. Okay, just like a quadratic, that a parent quadratic. And then an odd function, if I drop in a negative x, where I see an x, I'm going to simplify it as a negative times the entire function. And so you'll have a negative outside of the function, and that'll just basically look like the original function. And that is 180 degrees rotational symmetry around the origin. Or you can say it is reflected over the x and reflected over the y. And that's something like a cubic function. Okay. So take a look. And you can write the equations for these. That's f of x equals x squared. And that's f of x equals x cubed. Okay. So let's go over these right here. So basically, we could say that this has an x to the 0, okay, which became a 1. We simplified as a 1. And there was really no x. I mean, after you simplified it, it becomes f of x equals negative 9. So if I put in, therefore, if I put in negative x, it's still going to be negative 9. So therefore, f of x equals f of negative x. Okay, because negative 9 equals negative 9. So this is going to be an even function, and it's symmetric about y equal or is it x equals 0 or x equals 0. Okay, next one. This is a linear function. If I drop in f of negative x into the function, I get 5 minus 3 negative x, and so that's going to produce a y plus 3x. And if I compare the original function with the new function, they are different. Even if I take out a negative from here, I get negative 5. I get negative 5 minus 3x. Yes, that's going to change the sign, or make it the same as the original function, the sign of the term with x in it, but it's not going to make the term with the constant, which is negative 5. It's going to be a different term. So f of negative x does not equal f of x. It doesn't equal the original function because each of the terms has to be the same. Okay, they both have to be a positive and a negative. Okay, and then f of negative x did not produce negative f of x. It's not the factored out form because we tried both. That does not equal f of x, and that does not equal f of negative x. It doesn't equal, negative f of x. So either way, it doesn't equal either one. So this would be a neither. So there would be no symmetry. Another thing that I told kids that came to tutoring is if I break that apart and write it in standard form, that'll be x to the 1, 5x to the 0. Now, in a this is a linear function, but it could be a part of a polynomial function. Okay, if you look at each of the terms, in order for them to be even, they would have to have an even exponent. 0 is considered even, but 1 isn't. Or if they're considered odd, they would have to be both odd. So this includes even, a mixture of even and odd. That's why it's neither. Okay, good job. Next one, if I had f of x equals negative x minus 5. Okay, I just rewrote that. I don't know why I did that. And I'm just going to drop in a negative x. Okay, I can actually take out a negative 1 from here, and it's going to be x plus 5. And then once I take out a negative x, whoops, I forgot the negative there. Negative, and so I could take the absolute value. Because these are two factors, these are two separate factors, I could take the absolute value of negative 1 and multiply it with the absolute value of x plus 5. And in doing so, up here, this implies there should be double lines right there. Ah, that's so ugly. Okay, forget it. Okay, that implies that f of negative x equals negative, absolute value of negative 1 is just going to be 1, and then x plus 5. Now, the factor outside of the absolute value is the same, but let's take a look at what happened to inside the function. When I dropped in a negative, it became x plus 5 after I've simplified, and what's inside the function doesn't look like it. So therefore, that's way too many dots. Therefore, f of x does not equal f of negative x. And if I were to factor out another negative 1, if I wanted to, if I were to factor out a negative 1 from there, that would be negative x minus 5, absolute value of negative 1. And then if I take this out, it becomes positive 1, negative 1, absolute value of negative x. I could do all kinds of sorts of stuff, but it's still not going to look like a negative 1 being factored out. It's not going to change this to a positive. That's what I'm trying to say. If this were to say if it was positive 1 and there was nothing out there and it was x minus 5, okay, then that would be a negative f of x. That would be what negative f of x would look like. But it's not. It's the opposite. It's not you can't change that negative 1 to a positive 1. Well, you could. No, you couldn't, because whenever you take out a negative 1 from the absolute value, it becomes positive. It can't happen. Sorry. Okay, so f of x, well, there's too many therefores. Oh, does not equal negative f of x. So therefore, this is neither. Okay? Okay, next one. Your fave. Radicals. Let's go ahead and drop in a negative x. I'm going to put a cube root, put a negative x in there. Okay. By the way, that previous one, once again, because negative 1 times x to the 1 minus 5x to the 0. Now, if that was x to the third, that would be a negative and a negative, but then you still take out the negative. Absolute values, man. It'd still be a negative. There's really no way for that to be an odd function. The only thing that it could be is it could be even, the absolute value function. If I had a negative x to the negative 3 there, if I had an x to the negative 3 there, okay, then I could make those both negative, and whatever I take out, it'd be positive, and then that inside would look exactly like that, because that would be negative x and a negative, well, negative 5x cubed, well, x cubed, and that would be a positive, and if I factor, it would, if I factored a negative 1 out, if I factored a well, okay, this is wrong. Okay, and if I factored a negative x, I don't know what I'm trying to do. If I factored a negative 1 out, and then that came out as a positive 1 of the absolute value, then I would still have x minus 5x cubed, negative 1, and it would look like the original function. And that could be even. Whoa. Okay, anyways, that was too much math. Okay, so let's take a look at here, and then I have a cube root, negative x minus 4. Okay, f of negative x. Now I'm going to take out a negative 1, x plus 4. Now, since it's a cube root, I can say, hey, negative 1 times negative 1 times negative 1 is a negative 1. So I could take that negative 1 out of that cube root, and that would just become a negative 1 when it comes outside. So negative 1, and then a cube root of x plus 4, because that has to stay inside. So f of negative x equals that. If you take a look, yes, we factored out a negative 1, so it kind of looks like that. But then the x plus 4 is not f of x. It's not what we started off with. It's not this right here. It's not the same thing. So therefore, this doesn't equal that, negative x. And then it doesn't look like the original function. So f of negative x does not equal the original function. So therefore, this thing is, did I put neither for this one? This is neither. All three were these. Back to back, neither. Now, if I had the original problem be x to the 1 minus 4x cubed, okay, and I dropped in a negative, and that became negative x, and that became a positive 4x cubed, and I factored out a negative 1, x minus 4x cubed. I could take that out, and that would be a negative 1. And inside the radical would be x minus 4x cubed. That would look like the original function. So f of negative x would actually equal f, or negative f of x, because it just has a negative 1 outside. Okay, notice this is once again odd and odd. Both of the terms have an odd. Here, if I rewrote this, it's too purple right now. Purple is definitely not one of my favorite colors. Okay, and so if you take a look, it says x to the 0. Once again, even and odd. We have a mixture of even and odd terms. Well, even and odd terms with, well, we have a mixture of terms. Okay, we have a mixture of terms with their exponents being either not consistently even or odd. Okay, but if it was consistently the exponents were even or they were odd, it might work depending on what you need to, how you simplified, and what was making that function. It's the function. And I'm talking about what's making the function a function, meaning this is a cube root function. Okay, and so that was neither. Now, take a look at this. Now, could I put an x to the 0 here? Yeah, of course. Okay, so if I drop in a negative x, that negative x goes in to the exponent, the base, with an exponent 6, and that goes into, voila, and 3, and then that just is 1. Doesn't matter. I could drop in, I mean, come on. You want to try? There you go. Negative x raised to the 0 is just 1. Okay, so that's going to make it x to the 6th, because I could split the negative 1 and x, and then take the 6th of both, minus 2x squared, and plus 3. Now, because this is a collection of terms with a consistent exponent on the variable that's even, this thing is even. This thing is even. Okay. Now, next one. I'm going to put an x to the 0. You already know. Hey, I figured it out. I figured out the pattern. Okay. If you figure out the pattern, then I don't even have to do the algebra, but I'm still going to do the algebra because I have to justify it. This justifies your logic. Always you have logic, and then you need to justify it with math. It's kind of like a hypothesis in science, and you have to test it in order to justify your hypothesis. No matter how right you think your hypothesis is going to be, it's still a hypothesis. Okay, and so we have a negative x cubed minus 5. Okay, then that's going to be a negative x cubed minus 5. If I factor out a negative, it's going to give me that, which does not look like the original function. So f of negative x does not equal negative f of x, nor does it equal, okay, I don't want to put I don't want to put not equals because, yeah, well, I could. It doesn't equal the original function. None of those are equal to each other. Okay, wow. So this is neither. Okay, I don't want to go all the way over there. I'm just going to put neither here. Neither. Okay. If you already know the pattern, then you know this is going to be odd. Okay, f of negative x equals negative x cubed minus 5 negative x. Once again, math, you have to justify your answers. You can't just put an answer down and say, hey, I think it's this because I just guessed it. Okay, no matter how smart you are, you have to show justification. Okay, anyways, x cubed plus 5x. Now let's go ahead and factor out a negative. Okay, f of negative x, and that looks like negative f of x. So f of negative x equals, so this is odd. Okay, and it has that rotational, 180-degree rotational symmetry about the origin. Okay, and we don't have to call it clockwise or counterclockwise because 180 degrees rotational symmetry is the same thing. It affects x separately and y separately. You need to negate the x and negate the y. Okay, wow. Look at this one. Funsies. Okay, so f of negative x equals negative x 1 minus negative x squared. So x equals negative x square root of 1. And that's just going to be right there. I could separate out as negative x and x. And then I can just square the two. I could apply that exponent to both. Okay, and what you notice is that it squares the negative 1, so it's just going to be x squared minus x squared. Okay, what did it do? Did it do it? What happened? Oh, this is interesting. Anyways, yeah, so this one's a little bit interesting. Okay, so f of negative x equals, this is already, we've already factored out, if I want to write it, 1 minus x squared. You see that negative 1 there? Yeah. Hello, negative x, and then square root of 1 minus x. Oh, what am I doing? And all of this right here, after the negative 1, I'm going to just write it there. Negative 1 times x. All of that right there just looks like the original function. Right here. It looks like the original function. So therefore, this is odd. And this is a collection of odd and even exponents, but still somehow, because of the fact that the x squared, the x raised to the first power was not inside the radical, and each of the variables were not, they didn't have a special operation done to them, and it was separated out, made this an odd function. Okay? Cool. Good job. Bye.